Hey. All right, go away, sir. You have the
All right.
con.
Okay, science. Here we are. This is the science building in Western. In case you didn't know, I always start with this because there are, especially here in Danbury, there's a few of the audience that are alums. Also, I'm always trying to encourage young folks to check us out and consider coming to our university for education. Well, let me back up by saying a few years ago, you all remember, what was it, 2 years ago this summer? Well, anyway, I was on a particular day, I was doing a talk like this, slightly different topic, but climate change, to the League of Women Voters in Reading. And I go into the little cafe there where the meeting was being held, and it was all blue sky and beautiful. I came out and it was all yellow. You remember the day, probably. And we had some pretty hard breathing. I'm sure it was quite hard on anybody who had to put up with it with any kind of respiratory disorder, emphysema or anything like that. It must be awfully hard on them. But it was something that in my years here I had not seen, although I saw it in Alaska, where fires are fairly common in the summertime. But this was a fire in Canada, you remember, that blew smoke down here. And this is a picture of Chicago, I think. And they had a smoky few days, and so did New York City. Pictures were taken and published on New York Times website, showing some pretty awful air. And it was just the fires up in Canada that week, which were terrible. Now, fire as such is nature's reset mechanism. It's not a bad thing. It's something that happens as a natural phenomenon. We, of course, don't really like breathing all that smoke, or we don't like it messing up our vacation plans or aggravating health problems and all that sort of stuff. But it is a natural thing. When I lived in Alaska all those years, or went to grad school, occasionally there'd be fires away from Fairbanks, and the wind would blow it in, and it would be pretty smoky. The fires there aren't particularly big, at least the ones in the interior. So it wasn't like this. It was something a bit smaller. Anyway, these things happen. Generally, they're natural, but sometimes they are caused by humans not being cautious or doing something silly or what have you. That particular fire, this is a map of the fires on August something or other. It's covered up by a little 14th of 2023, showing the active fires that were going on in Canada at that time. Anything that's in yellow there is one that the Canadian Fire Service had under control. Well, they knew that it wasn't going to get worse, and they knew eventually it would burn out. Anything that is in green, they had a pretty good idea that they had it under control or would soon. And then anything in red, which of course is most of them, was out of control. They were just trying to do what they could to minimize the damage. Some years ago, there was a big fire that blew through the Alberta tar sands petroleum site and caused well, pretty awful conditions. There's nothing unusual about Canada in this regard, except for they have a lot of forests, and forests burn periodically. Let's see here. Is two. There we go. That same year, a little bit later in the year, or maybe it was the same year? Wait a minute. 23. Yeah, it's about the same time, a few days earlier. You could see that it had been particularly hot up in northern Canada, northern Alaska too, for that matter, and areas that typically don't have heat. Now, these are heat relative to the way things normally are in those spots, not heat like you'd find in Arizona. But it was a hot summer. And the 14th of August, 2023, this is the Canadian fire map showing the danger levels as they figured it throughout Canada. So the Yukon, low danger, and most of Quebec and Newfoundland and Maritimes were low as well. But southern Alberta and the southern part of Nunavut were were extremely dangerous in those at that particular time. That's the fire that smoked us up. Now, the fires in Canada and the fires in Alaska and the fires in the Mountain West and upstate New York and other places like that are most frequently found in coniferous forests, which tend to burn because they're quite flammable. The worst fire season in Canada in 2023, in 2023 was the worst fire season in Canada since, move this thing out of the way, some earlier date, and it's covered up by yeah, for decades. So it was a pretty bad one. And fires have a couple of different kinds of emissions that are of concern to us. One is all the wood and green stuff that was created by those trees via photosynthesis meant taking CO2 out of the atmosphere, which we consider that a good thing. And when you burn it, of course, puts that CO2 back in the atmosphere. But there's also things, particulate matter, that we perceive as smoke and soot, which is or partially combusted material associated with the wood, like the leaves and needles and things like that, that will get up into the air, cause a lot of distress for people downwind. The particles will move toward the east, generally speaking, eventually anyway. And some of them will settle out eventually, and some of them will settle out on top of ice. And when you have soot that is riding the jet stream, riding the natural flow of air up in the Arctic air mass, settle out on ice, it causes a reflective surface to be much less reflective. The term is albedo. Albedo is how reflective a surface is, and it's a very important concept in understanding climate change and climate dynamics in general. And so by sprinkling soot and things like that on the ice in the Greenland ice sheet, you're increasing its likelihood to melt as you're making it less reflective. Same with Antarctica, although there's a lot less, there's not all that much forest in the southern hemisphere, so there's not that much fire of this sort, and so there's not that much soot settling on that ice in the south. Anyway, it's a big deal. So whenever there's a fire, that's one of the effects. It's all the CO2 being put back in the atmosphere, but it's also all the gunk. Those areas in this map, those areas in the U.S. that are shown in red broke records for smoke pollution. And so those were areas that were particularly smoky, and those were in the West. I mean, pardon me, in the Northeast of the United States, but a few in the West as well. Now, so fire, as I got ahead of my slides there, results in CO2 and soot. Those are two things that are important. Now, scientists think that there are three things that we need to address, first of all, to help control climate change. One of them is soot. Okay. Soot's the stuff that comes out of my wood stove. It's the stuff that comes out of the tailpipe of your car. It's the stuff that comes from burning anything. And well, burning wood anyway. And it has the effect of causing ice to melt faster. The other things are methane, which is natural gas. It's a byproduct of petroleum and coal mining, and it's also a very strong greenhouse gas. And the chlorofluorocarbons, those industrial gases that are used as refrigerants, those are the devil's own greenhouse gases. And we need to figure out a way of replacing them with something that's less dangerous. So soot fires are significant to climate change because of, if nothing else, because of the soot. Now, there are ecosystems in the northern hemisphere. Like I say, there aren't that many forests in the south, and so my generalities about ecosystem ecology are going to be more applicable in the north. But there are forest ecosystems that normally burn, and if they burn frequently, then the fires are not so severe. If the fire is suppressed, because we don't want to ruin our pool parties, or we're protecting our homes and things like that. If we're suppressing the fire, then the fuel builds up, and so when the fire occurs, which it always will eventually, it's something really dangerous. Well, grasslands typically burn regularly. They have a relatively small amount of biomass, so the fires are generally not too severe. Chaparral and Mediterranean scrubland, that's what you have out in the Southern California. We'll talk about that in later. But there's also bits of that kind of ecosystem in Australia and the Mediterranean region and South Africa. Then coniferous forest. Coniferous forests tend to burn because they're combustible, and that includes the southern pine lands. It includes jack pine up in the Great Lakes area. In fact, jack pine actually needs to burn periodically in order for it to grow more little baby pine trees. And taiga forest, the northern boreal forest, like what we had in Alaska, and some of what burned in Canada just a couple years ago. No, as the world warms, this is how it works. You can work out a kind of chain of consequences, and to understand how the warming of the climate is going to affect other things. And in this case, more warming means more energy in the biosphere. The biosphere being that part of the world that supports life. Okay. More energy in the biosphere, more heat on the surface. Warm air can hold more water, and that air then warms. And when that air warms without added water, it becomes less humid and dries up. Dry air then sponges up nearby water from the environment and makes fires more likely. So dry blowing air over the terrestrial environment will dry it further. Stronger wind dries more severely. Strong wind fans the fire. One of the reasons why the Dust Bowl back in the 30s was so severe is that it was dry and got drier every year because of the same phenomenon. They didn't have fires to speak of because it was largely farmland that was blowing, but it was blowing because it had been drying for several years, and dry air makes the land drier. You get fires in places where you don't expect them to be. Maui. Unless you live on Maui, you probably didn't expect Maui to have a wildfire, but it did a couple years ago for reasons that That probably should be a talk all by itself. But it was a fire that got out of control and destroyed a lovely island. I mean, it destroyed some of the environment of a lovely island that lots of people like to visit. Another thing we're starting to see now that we have more energy in the biosphere, and that's something called a flash drought. Okay. We're starting to see a lot of weather patterns that are coming on fast, and they will start up. You don't see them coming, and they're happening quicker than they used to. And that's all a function of there being more energy in the atmosphere. And so a flash drought is a type of drought characterized by a rapid onset, intensification, and increase in severity over a relatively short time scale, usually a few days or weeks. Okay, faster than a drought usually takes to get going and cause disruption. Now, fire requires three things. It requires fuel, it requires oxygen, wind, and it requires a spark. These can come from natural things. The spark can come from human carelessness. This is the chaparral. This is the kind of vegetation you find in the mountains above LA, and as well as in some parts of the Mediterranean basin and, like I said, South Africa and parts of Western Australia. And this is a fire-affected ecosystem. It normally burns frequently, and when it's allowed to burn frequently in a natural way, then it will keep the amount of fuel low, and so the fires don't get out of control, generally speaking. When we suppress the fires because it's inconvenient to us or we're protecting our property, then the fuel builds up, and so when the fire comes, it's something that is easily gotten out of control, and they turn out terrible. The oxygen in the California fires was supplied by a particular weather formation called the Santa Ana winds. On the other side of the mountain, over the Central Valley, I believe, there'll often be a high pressure system set up, and the high pressure system then pushes air. Wind blows from high pressure to low pressure, and like temperature goes from hot to cold. The energy moves from hot to cold. So high pressure, low pressure. And so the high pressure spins out winds that will blow down the mountains and get confined into narrow gaps between the mountains, so that it's like taking a big pipe and carrying water and moving it all to a small pipe. It means the water is going to go through the pipe a lot faster. And it's the case with the Santa Ana winds, which a stronger wind fans more flames. And that's what they have. This is something that they're used to, the Santa Ana winds, and the fires that happen occasionally and catastrophically. Now, the spark in a natural fire is, well, with the exception of volcanoes and things like that, the wildfires are usually lit by lightning, dry lightning. There is fairly frequently where you'll have a lightning strike that's not followed by rain, dry lightning. And that's what starts most of the fires in the American West and in Alaska, and probably Canada too. And I've always been a fan of lightning storms from a distance, of course, because of the beauty of them. But they hold a very large amount of energy and can cause a lot of damage. Now, those areas which are prone to fire are of a fire climate because it has these characteristics. Okay, if you have a environment that typically has a wet time of year where the plants grow and the fuel accumulates, followed by a long dry time of the year, which dries everything out, followed by dry lightning. And the addition of flash droughts and heat domes increase the likelihood and severity of these fires. Now, in a warmer world, on a warming planet, any environment which gains these characteristics more strongly are going to have an increased likelihood of having a burning. Okay. If climate change is causing there to be more wet periods followed by dry periods and dry lightning, then those areas will eventually be more likely to burn. Now, there's another aspect to this that ecologists talk about as a way of trying to explain why some environments, what the ecological effect of a rainy climate versus a not so rainy climate is. For instance, Fairbanks, Alaska, where I went to grad school, and Santa Fe, New Mexico, have almost the same amount of precipitation every year. And yet, Fairbanks is a moist environment and Santa Fe is a dry environment. The difference is this. In Santa Fe, it's warm. And so you have a potential for movement of water from the surface to the air through evaporation and through transpiration. Transpiration is evaporation that is mediated through trees and plants. They do that to cool down their leaves, which are little greenhouses. Okay, so the potential of evapotranspiration in Santa Fe is high because it's a warm environment, much warmer than Fairbanks, and so the potential of evapotranspiration is high. However, the actual evapotranspiration may not be all that high in Santa Fe if they don't have very much rain. Okay, Fairbanks has rain, but not hard rain, not big frog strangling gully washers like we used to call them in Missouri. But because the rain falls in Fairbanks does not evaporate as quickly, it's a moister environment than Santa Fe. And so two places, two different latitudes, have the same, more or less, the same precipitation regime, and one's wet, one's dry. Okay. If the potential for evapotranspiration far exceeds the actual evapotranspiration, then the local climate is drought prone. That's how it's defined by ecologists. All right. Another thing, as the world warms, the frost-free season will get longer if there is frost in areas where there is frost. In any case, the warm weather season will get longer. And the season where fires are likely to happen will also get longer. Longer fire seasons. Warm weather will arrive earlier and stay later. And there'll be smaller snowpacks and earlier melts, and forests that are considered combustible about a month after the snow melt ends. So they will be combustible longer and have a much longer period of likelihood of burning. So you'll also have in a drier world, at least in some places, drier conditions. And another thing is that in a warmer world, we'll have insects that infest forests and kill trees or kill limbs of trees become more common in different places than they are now. And when a mountain pine beetle it lives in an area that is warm enough where they survive the winter and can reproduce quickly, then they will infest more trees, and those trees then will have more limbs that are prone to burn. So the environments that are that typically burn have something called a fire frequency, a fire return frequency. It's how often they burn. For instance, um, grasslands tend to burn more frequently because after they burn, the grass grows back up fast. And so a short grass prairie burns every 5 to 10 years in a natural state if humans aren't mucking around with it. And a tall grass prairie every 2 to 4 years because they produce enough biomass to enough fuel for the fire. Oak hickory forest are in a wetter climate, and they will burn less frequently because there's less biomass on the ground, 200 to 400 years and so on. The boreal forest is 70 to 100 years, although there are some areas that burn less frequently. There was a area where I was taking soil cores around Fairbanks, and when I was doing my PhD. And I took a core and I looked at it, and there was charcoal in it. So I knew there had been a fire, and I asked the local expert, the wise old man who knew so much about the history of that forest, when this fire was, and he said 1776. Usually the taiga forest burns more often than that, but that is a spot where you had very mature white spruce trees, and it hadn't burned in a long time. Okay, so different areas will burn more frequently or less frequently. Northern hardwoods burn less frequently, in part because it's a moist climate around the lake. Now, some plants, some conifers, such as the jack pine, here are the cone, 2 cones of a jack pine, and while the parent tree is alive, the cones stay closed, and the seeds can't fall out and start growing because pine seedlings need light, and they cannot grow well in the shade of a large tree. And so what they do is that whenever there is a fire that heats the cone and causes it to open up, it's called a serotinous cone. And it causes it to open up. And at that point, when the mother tree is dead or dying or much reduced in size, the seeds pop out and they have a chance of actually getting going. And there are other trees that do this. I think some of the redwoods do it, and black spruce does it to some extent. There are areas of the world that, because of climate, they are more fire prone, and also by the fact that the areas in Central Africa there that are kind of in the middle, not the one that's sort of down the Congo Basin, but the ones above that are areas which are savannas and grasslands anyway, and so they burn fairly frequently. Okay, so annual average fire density between these 20 years, 2000 to 2020, and you can see that some of the most intense fire frequencies were in Africa. Also in areas which used to be called the Amazon, but have been cleared for the production of soybeans and cattle and burned. And northern Thailand, when I lived in Thailand, up in the north, up around Chiang Mai, the farmers didn't burn the rice stubble in the fields, but now they've gotten in the habit of doing it, and I'm not sure exactly why. But it causes a lot of smoke to get into the city of Chiang Mai, making it a pretty bad air quality place, much worse than it was when I was there in the 70s. And so this map shows the recent wildfire frequencies and activity in various places. The red are more fires, and the green are less fires. So you can see where those are taking place. And the days of exposure to very high or extremely high wildfire risks And you can see that Southern Africa is at risk for much, as is the areas Kazakhstan and Mongolia, which are grasslands. And the dominant factor contributing to what makes an area burn would be the amount of fuel, the amount of moisture, the ignition from fire, from lightning, and fire suppression, suppressing fires, causing fuel to build up so that fires occur eventually. So there are patterns for this as well. Now, all fires are not the same. There are some fires that are relatively low intensity, ones that do not jump up in the canopy of the trees, that burn up the dead twigs and dead leaves and stuff in the bottom of the forest. And they often can burn out before they kill the trees. It's called a ground fire. If, however, the fire gets up into the canopy, that's a different story entirely. One of the reasons why being a fighter is such a dangerous thing is the fire is so heavily influenced by the wind. And the wind changes direction, the fire changes direction. And people lose their lives being fire being firefighters. I guess it's exciting, but it's not something I would be inclined to do. I guess they're all young too. In Australia, there's a particular kind of fire, a kind of cumulus cloud that will form in response to fires upwind, and then it will actually cause rain downwind. Kind of a quirky thing. The smoke plume goes up and it cools and it forms a cloud of water droplets, then blows downwind and then causes a downburst of wind and lightning downwind of the fire itself. And they call that a pyrocumulonimbus cloud. Now, wildlife, of course, also have to deal with this, and the wise old elks in Yellowstone, when they have a fire, they'll go stand in the middle of the river where it's cooler and they're farther from the fire, and it's a safer place to be. Now, the fire can come and kill an area of forest, and it looks like the wrath of God, as my grandmother used to say. It looks like a terrible event. And then the next year, the wildflowers come back. There are a number of different species of wildflowers that have wind-blown seeds that are adapted to invading areas the few years right after they have burned, because at that point there's more sunlight reaching the ground. And one of those plants is this one. It's epilobium, called fireweed, and it's all over the place in the American West and the northern part. In Alaska, is anywhere you have a disturbed soil like road work and all that, you'll have epilobium growing, and it produces this stalk, and it starts blooming at the bottom, and it's like a thermometer. When the fireweed reaches the top of the stalk, you know it's just about time for snow to come. That's the folklore around Fairbanks. I also saw this plant in Siberia, and which is also a fire affected ecosystem. Only it's not spruce; it's larch, Siberian larch, and it's a different species and a slightly different color. I took a picture of it. I have it somewhere. But I've always liked fireweed. It's a very pretty flower, and it is a harbinger of hope after the disaster of the fire. Now, if any of you would like to take a course and learn more about climate change, I'm advertising here. In the summertime, I at least try to teach a 4 credit science of climate change course by 150 at Western, just up the road from the Danbury Library, and it will be in July, and it'll be 5 weeks long. And if you're interested, if you have children or grandchildren or nieces or nephews that would need the general education science credit, send them my way. All right. That's what I have, and I'd be delighted to try to answer questions as always. If I don't know the answer, I'll tell you I don't know the answer.
Hey, we have a question from Bill. Are the forest fires of North America similar in Siberia?
Well, the Siberia is, well, I've only seen a relatively, it's a huge area, and I've only seen a part of it. And the tree species are different. The main, at least in eastern Siberia, in Yakutia, which is where I was, like I say, they're Siberian larch, but they're still evergreens, and so they're still going to burn. And I saw the same sort of forest stands at different sizes that you find in Alaska. So they're going to be similar. Whether they're exactly the same, I can't say.
And what type of fire was in West Texas earlier this year?
I have to think that it's probably a grass fire, but because I don't know how many forests, there may be pines. There's probably pines in West Texas, but I think most of those are even in East Texas, but I'm not sure. I have a fish and wildlife degree, but I don't have a forestry degree. So
Folks, you have any other questions, please just type it in the chat. And do you know anything about the smoke from New Jersey? I know we spoke about this before we got on, but do you know anything about that, or this is the first you've heard of it?
well, I know I heard about it a couple of days ago. Whether it comes up to us or not, it kind of depends on which way the wind's blowing. Um, and in the temperate zone, the wind tends to blow east to west. So maybe we won't get much of it. The reason we got Canada smoke is that in the north of about 40 north latitude, you have the boreal zone, and where that fire was, and that wind blows west to east. And so some of that and the particular shape of where the um, the boundary was between those two cells let all that smoke come down on us. That's all I know.
So I guess we don't have any other questions for this evening. I just want to thank you for, again, continuing this Earth and Crisis series with the Danbury Library. We really appreciate your time and your expertise on this, Professor Wagener. I encourage everyone to check out the summer of reading workshops and presentations that we have coming up. I think in the next few weeks, you'll see them in our calendar of events. And just be sure to take note of our Sustainable Future talk series. That's going to be with Professor Wagener, and that's going to be in mid-July, and that will be in person here at the Danbury Library's Maker Lab. So be sure to come down and, talk about certain topics that Professor Wagener is going to talk about, and we can discuss it face to face as a community. So we encourage everyone to come down and take part in this workshop, as well as other workshops that we have here at the Danbury Library. And we will see you next time for Earth in Crisis. So that'll be next year in January, starting up that time. We haven't discussed the topics yet, but I'm sure it'll be of most interest to everyone. And again, my name is Aurelio Muraca on behalf of the Danbury Library and the Friends of the Danbury Library. We thank you, and we encourage you to, make little differences as much as you can. And again, thank you, Professor Wagener, for always being a part of our community and enlightening us with your knowledge and expertise.
See my shirt? It says climate change education. That's what
I love it. I
That's what
love
we
it. Okay, go outside, enjoy the beautiful weather, and if the smoke comes, just don't try not to breathe it in. All right, everyone. See you next time.